Greetings students and welcome to class. Today we are going to be looking at direct variation, which is a topic in algebra. So by definition, if two quantities are related such that an increase or decrease in one quantity leads to a corresponding increase or decrease in the other quantity, then we can describe this relationship as a direct variation. So take for example the salary of an employee who works for a certain number of time or a certain period of time. So if that employee works for a longer period of time, his salary will increase, and if he works for a shorter period of time, his salary is going to decrease. So the number of hours you work for along with your salary, these two quantities varies directly. Another example of direct variation could be the distance a car traveled at constant speed and the time the car takes to travel that distance. So the more the time increases, what happens? The distance also increases. So distance and time at constant speed will be related directly, or we say that the relationship between distance and time at constant speed will be a direct relationship. So we are going to give you the mathematical definition of direct variation, and then we are going to solve a problem. So let's begin. So we say if y varies directly as x, then this relationship can be written mathematically as y varies directly as x. So y is proportional to x. And if you get rid of this proportionality sign, you have y is equals to kx. So y is equal to kx is the actual equation describing y varying directly as x. Varying directly as x. So now what we are going to do is to derive a formula that we can use to solve all of the problems under direct variation. So again, this k is called a constant of variation. So it is called the constant of variation or the constant of proportionality. If y and x are related, then there is a constant multiple with which the both of them are related, and that's k. Good. So we have y1 is equal to kx1. So y1 is equal to k times x1, and from this we have y2 is equal to kx2. Now if we make k the subject in each equation, for this side we make k the subject, we divide this side by x1 and divide this side by x1, we are going to have, this is what we are going to have. If we make k the subject, we are going to have k is equals to y1 over x1. So this is y1 all divided by x1. And for this, if we make k the subject, we are going to divide this side by x2 and divide this side by x2. So we will have k is equals to y2 divided by x2. That's what we're going to have. Now, the constant will be the same for whatever values of x1, y1, and x2, y2. So we say but k is equals to k, meaning the value of k here is the same value of k here. And if you equate these two quantities, you have y1 over x1 is equal to y2 over x2. And this is the formula we use to solve problems under direct variation. Now, from here, we are going to look at an example of how we can solve problems using this equation. And then after then, we give you an example to practice, and let's see how it goes. So we have an example on the board. We are told that a car travels 330 kilometers in 5 hours over uniform speed. That means the car had the same speed for the entire 5 hours. And then how many hours will it travel? 4,290 kilometers. So what we're going to do here, first of all is to identify that this problem is a direct variation problem, because when the distance increases, the time also have to increase, and when the distance decreases, the time it takes to cover that distance will decrease at constant speed, remember. So let's write the relationship between the two variables. So a car travels 330 kilometers, that's our distance, in 5 hours. So the two relationship here is distance and time. So writing the relationship, we have distance is equals to k times the time. Remember we said y was equal to kx. So in this case we have distance and time. So d is equal to kt. Now we are told that the distance is 330 in 5 hours. So this d is represented as 330 is equal to k times the value of t is 5. This is an equation we have to solve for the constant k. So 330 is equal to 5k. To solve for k, we divide each side by 5. So divide this side by 5, divide this side by 5, 5 and 5 will cancel out. So k will be equal to, if you divide this, if you divide 330 by 5, you are going to have 66. So k is equal to 66. Good. Now that is the constant, the constant that relates the distance and the time. So therefore the equation connecting distance and time will be d is equals to kt, but k is 66, so that's 66t. Great. Now using this equation under this very same condition, we can find any distance at any time. Given one of these quantities, we can find the other one. So you are told that in how many hours will it travel 4,290 kilometers? Now this is the distance and we are told to find the time. So 4,290 is equal to 66t. Great. So to find the time, you divide both sides by 66. So we divide this side by 66 and divide this side by 66. So we have 4,290 divided by 66. You are going to have 65. Therefore, 65 is equal to t. Implies, there's the implication sign. That means this implies that t is equal to 65 hours. Now, in order for the car to travel 4,290 kilometers, it needs to have traveled for 65 hours. So we are going to give you an example that you can also work on. You have a practice problem on the board there. If v varies directly as I and v equal 10 when I equal 5, find I when v equal 100. So solve that and post your solution in the comment section, and then we'll be able to respond to you from there. Thank you very much for watching, and hope to see you in our next video.